All right, let's do section 9.2, page 454, number 17, which reads, identify the indeterminate form and evaluate the limit using L'Hopital's rule. And for number 17, we have the limit as x goes to 0 from the positive direction of x times the natural log of x. Now we've been talking about all these different ways that we have for evaluating limits, and one of the important things to do at the beginning is to graph. So I'm going to go over here and I'm going to make a little sketch, and I'm going to graph x times the natural log of x. And when I do that, I get something that kind of looks like this. And this is going to be 1 over here. So it looks to me like maybe the limit as x goes to 0 from the positive side is going to be 0. But we really can't count on that. We need to see what it's going to be analytically. So our second method for evaluating limits is to substitute in. So if I substitute in here, well, I know that x is going to be 0, but what's going to happen to the natural log of x as I approach 0? Well, I think we should graph that as well. So I'm going to put this on the same graph, but I'm going to use a different color, and I get something that looks like this. So I'm going to go back to my purple, but I need to change my width here. So in the limit, as x goes to 0 from the positive direction, the natural log of x is going to go to negative infinity. So my indeterminate form here is 0 times negative infinity. And that was one of the things that we were supposed to identify. Now this is an indeterminate form, which means I haven't found an answer. This doesn't have any meaning. I need to keep going. But unfortunately, it's not the right indeterminate form for me to apply L'Hopital's rule. So I've got to use the tricks that I was talking about earlier. So when we have 0 times plus or minus infinity, we're going to do a substitution. So we're going to substitute in x equals 1 over h. And it's really important that we remember not only to make this substitution, but to change the limit. So if we had x going to 0 from the positive side, we're going to have h going to 1 over 0 from the positive side, which is going to be the same thing as h approaching positive infinity. So let's do our substituting in and try again. So I'm going to have the limit as h goes to positive infinity of 1 over h times the natural log of 1 over h. And now I'm going to substitute in again and see what I'm going to get. Well, this is going to give me 1 over infinity times the natural log of 1 over infinity. So this is going to be taking the natural log of 0, and as we take the natural log of 0, we're going to end up at negative infinity. So this is going to give me negative infinity over positive infinity, and that fortunately is an indeterminate form that I can apply L'Hopital's rule to. And I've written L'Hopital's rule up here in the corner in green again, and it says that the limit as x goes to a of f of x over g of x, if that's equal to plus or minus infinity over plus or minus infinity or 0 over 0, then it's also equal to the limit as x goes to a of the derivative of f of x over the derivative of g of x. And remember again that I'm taking the derivative of f of x and putting in the numerator. I'm taking the derivative of g of x and putting it in the denominator. I'm not using the quotient rule here. So I've got my acceptable indeterminate form that I know what to do with, and I'm going to have to apply L'Hopital's rule. So what I have here is the natural log of 1 over h, and I'm going to take the derivative of the numerator and the denominator separately. So this is still going to be a limit as h goes to positive infinity. I'm going to take the derivative of the numerator, of the denominator first, because that's just going to be 1. Now, when we take the derivative of the numerator, I want you to remember that when we take the derivative of any natural log, the first thing that we do is put 1 over whatever the argument of the natural log is. And then we have to take the derivative of that argument and write it times this. So what's the derivative of 1 over h? Well, it's negative 1 over h squared. So there's going to be some algebra going on here. So we've got the limit as h goes to positive infinity, and I've got a negative sign hanging out front. And this 1 over h is really an h, and then I have that times 1 over h squared. So when I cancel everything out, I'm going to have the limit as h goes to positive infinity of negative 1 over h. And if I substitute in, I get negative 1 over positive infinity, which is going to give me 0. And graphically, that's what we thought we were going to get when we graphed x times the natural log of x.